Hello and welcome to a Telecom Innovator video from Light Reading. My name is Phil Harvey. I'm the editor-in-chief of Light Reading. And this video series is a sponsored video series where we take a deeper look into the people, places, and some of the ideas that are moving the telecom industry forward. Joining me today here at Cisco headquarters is Bill Gartner from Cisco Systems. Bill, thanks for being here.
Bill, thank you for having me.
We're here in the Cisco campus,
Yes.
the sprawling Cisco campus in San Jose. I want to talk about, how networking is changing. From our point of view, we always track optical networking and fiber optics.
Mm-hmm.
And fiber optics is having sort of a renaissance or a moment in the spotlight with the advent of AI. So how does fiber optic connectivity influence AI or help it evolve both inside the data center and outside the data center?
Yeah, optics is sexy again, and we're all delighted about that. I think within a rack, copper still prevails, at least today, but copper has limitations in terms of how much capacity it can carry and over what distance.
Okay.
And so as the bit rates increase from 100 gig to 400 gig to 800 gig and beyond, fiber becomes really the preferred media for carrying those signals. And certainly as you extend the distances beyond a single rack into multiple racks, fiber really becomes the only media that's available to carry those signals. And then obviously as you leave the data center and now want to send a signal to a remote data center across a city or across a country, you obviously need very, very high capacity capability, and that is available only on fiber as well.
Okay, and this is not just because of the bandwidth constraints for copper, but what are some of the other characteristics that are needed that fiber satisfies there?
So it's primarily a bandwidth distance product. So if you look at the bandwidth times the distance, at some point fiber becomes really the only choice for you. It's got very good performance capabilities. It's got very good resilience against noise and a very long lifetime. So fiber really is the preferred media for carrying these very high capacity signals.
What pressure does that put on, or how does it kind of evolve all the components that are, that the fiber is connected to? So optical interconnects come to mind. How is that changing, and what is Cisco doing in that space?
Yeah, it's actually quite a complicated issue because many of our customers have selected different infrastructures for their fiber in the data center.
Okay.
Some have parallel infrastructure, some have duplex infrastructure, meaning all the signals are on a pair of fibers. Some have single mode fiber and some have multi-mode fiber. Single mode fiber is really, I think, probably the preferred fiber as the distances and the capacity grows. Mm-hmm. You certainly would see single mode fiber in WAN applications and in metro and long haul applications. Mm-hmm. Inside the data center, it can be a mix of multi-mode and single mode, and that presents a challenge for guys like us that are trying to satisfy many customers because we have to help them evolve in the existing infrastructure. To go to them and say, well, all you have to do in order to go to the next bit rate is you have to replace your entire fiber infrastructure isn't a good selling proposition. So that means that we need to innovate with things like multi-mode fiber solutions that allow them to grow from 100 gig to 400 gig and beyond, and obviously single mode as well. I think an insight that has evolved from AI is that the reliability of the optic is much, much more important than it's ever been. In classical networks, TCP/IP tends to bridge problems. Mm-hmm. If you have a burst of errors on a classic network connection, you're not going to see it in your Gmail, and you're probably not going to hear it in your voice call, and you're not going to see it in your video, because TCP/IP tends to bridge those issues. In an AI application, that can be a devastating problem because in many cases that burst of errors would cause the workload to stop and restart. And now you've got very, very expensive GPUs that are either stranded or idle while that workload is backing up and restarting. And so the reliability of the optics becomes a much more pressing issue as we look at AI in the back end and in the front end application.
Okay.
And we are doing things in terms of the technologies we're selecting, like silicon photonics, which tends to approach the reliability of silicon rather than a whole bunch of discrete components. Our design methodology is one where we focus on building in sufficient margin, not only for day one, but for the lifetime of the optic over all operating conditions. And then we stress the optics through our reliability testing and our quality testing to make sure that they meet all industry standards under all operating conditions, whether it's voltage variation or temperature variation or humidity or vibration. I think nobody in the industry is doing the level of qualification and reliability testing that we are doing. And just as one data point, we, over the last few years, acquired 20 optics from various vendors, all of whom claimed compliance with all of the standards.
Okay.
None of those optics passed our reliability test. And so what we know is that there are a lot of optics suppliers out there that are checking the box and saying compliant, 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 but would not stand up to an AI application in terms of the reliability objectives. So that's inside the data center. Now, once you leave the data center, we get into what we refer to as routed optical networking.
Okay.
And routed optical networking, very simply, I'm going to use a prop if I can here.
Yeah, please. Yeah.
Routed optical networking, the idea is in a classic optical solution, you have a transponder. This takes a signal from a router or a switch and converts it into a DWDM signal that can travel over a long distance, very high capacity. And this is the classic approach for delivering optics into the metro and regional networks and long-haul networks.
Okay.
And we deliver transponders for customers that want transponders in their application. This sits in a chassis, and the chassis is something that has to be separately planned and maintained and consumes power. What we can do with routed optical networking is, instead of deploying a transponder that looks like this, we deploy a pluggable optic that looks like this. This is an 800 gig pluggable optic, and this can support about 1,000 kilometers. And so for many, many applications, whether it's a DCI, data center interconnect, or a metro application, or even a long-haul application, we can serve that now with pluggable optics. And that's really the basis for what we call routed optical networking. And I think it has very obvious benefits for customers in terms of economic benefits. It's 90% less power, generally. It's 60+% less cost, and 60+% less space. So the economics are super compelling, which is why virtually all the hyperscalers are deploying this technology, and we now have over 350 service provider and large enterprise customers deploying this technology as well.
Okay, that makes sense. And then where do pluggables go from here? Because obviously with that kind of space, power, and bandwidth combination, it's not just going to stay in fixed networking forever.
So I would say there is a continuous innovation that's occurring in this domain. We introduced 400 gig several years ago. We've expanded on 400 gig to support 400 gigs in classic ROADM networks.
Okay.
We've now introduced 800 gig, so we'll be increasing the bit rate from 400 to 800 and ultimately 1.6 and beyond. We're also expanding the distance. So initially the 400 gig was introduced for 100 kilometers, then 1,000 kilometers, and now we have an ultra long haul version of that can go several thousand kilometers. We recently announced with AARNet, a research and education network in Australia, a subsea application for a pluggable optic that went 4,600 kilometers. I think for any terrestrial application, whether it's DCI, metro, or long haul, pluggable optics has a role to play. But we're also looking at pluggables as a way to introduce other functions. So we've recently introduced a pluggable line system for customers that want sort of a very simple point-to-point line system and don't want to deploy a full chassis with all the power and maintenance associated with that. They can actually deploy that with a pluggable optic. So we'll see pluggables reach into other parts of the network and replace functions that are traditionally delivered in chassis-based solutions. And one other example is that we introduced a technology called routed PON, where we've taken the OLT, a standalone chassis delivering PON functionality, and put that into a pluggable optic. So I think pluggables we're going to see reach into many, many parts of the networking domain.
Okay. To wrap it up, especially going back to our AI discussion, how well is Cisco positioned when it comes to helping, be it hyperscalers, service providers, or enterprises evolve their network needs to fit AI?
I think I feel like Cisco is positioned in a terrific place right now. With our Silicon One technology, we have the right switching and routing platforms to serve our customers, whether it's a training application or whether it's an inference application that an enterprise might use. We have the optics portfolio today that can support AI applications for 400 gig and 800 gig, evolving to 1.6T. And then, of course, the focus will be on things like reducing power, improving latency with technologies like LPO and CPO that we'll see evolving over the next few years as well. So I feel very good about the portfolio we have. Cisco announced earlier this year that we do over $1 billion in AI infrastructure with web players. We've exceeded that, and we're very proud of that. But what we see ahead of us is much, much greater. So we feel really great about the portfolio, really great about Cisco's position in this industry.
Fantastic. Bill Gartner, thanks so much for your time today.
Thank you, Phil.